Hi students, today we are continuing with the Standard 9 Cbse Maths, and the chapter is the second chapter 2, that is Polynomials, chapter 2 of the syllabus, Polynomials, and under Polynomials we will be doing remainder theorem. So what is remainder theorem? The explanation is of remainder theorem is like this. So what is the explanation? Let Px and Gx be two polynomials such that the degree of Px is greater or equal to the degree of Gx and Gx is not equal to 0. So first, what we are saying, two polynomials Px and Gx, and here the degree of Px is greater than the degree of Gx, and also Gx is not equal to 0. So Gx is some real number, we know. Then we can find out. So if these two factors are satisfied, we can find out two polynomials. So the two polynomials what we get are Qx and Rx such that Px is equal to Gx Qx plus Rx. So again I will read it. What is the explanation given for the remainder? What is the remainder theorem? Let Px and Gx be two polynomials such that the degree of Px is greater than or equal to the degree of Gx and Gx is not equal to 0. Then we can find out from two polynomials Qx and Rx such that Px is equal to Gx Qx plus Rx. So Gx Qx is Gx into Qx multiplication plus Rx, where the degree of, again this Rx is less than the degree of Gx. So that is another property. What we get? The degree of Rx will be less than the degree of Qx. Okay. So this is the remainder theorem. The same thing we can show it in another way or explain it in another way. So the other way around, we can say that on dividing Px by Qx, by Gx, not Qx, by Gx, on dividing Px by Gx, we get Qx as quotient and Rx as remainder. So remainder theorem is this. Remainder can be either 0 or it can be more than 0 also. So for better understanding and explanation of this remainder theorem, here I have given an example. I have taken an example. What is the example? I have taken 13 and divided by 5. So 13 is divided by 5. So 5 2s are 10. 13 minus 10, 3. So here 13 is the dividend, 5 is the divisor, 2 is the quotient and 3 is the remainder. So here I have given an example. 13 Px, as per the remainder theorem, Px is 13. The polynomial 13, which is being divided by Gx, which is 5. Gx is 5 here. So what we get? 13 divided by 5, the quotient is 2. That is Qx, quotient. Okay, Qx is 2 and the remainder 3. That is 3. So plus 3. So you got it. Remainder theorem, Px is equal to Gx into Qx plus Rx. This is what is remainder theorem. And example I have taken, Px is 13. So 13 divided by 5. So 13 is equal to 5 into 2. That is 10. 10 plus 3, 13. What we get is 13 in short. So this is what is remainder theorem, and we have to use this remainder theorem to solve the sums under whatever sums will be solving under this subchapter, which is polynomials remainder theorem. I hope you understood this. I'll continue after rubbing this out more. So what is the first question sum we are doing? First one we will be doing is find the remainder. Find the remainder when x cube plus 3x square, when x cube plus 3x square plus x cube plus 3x square plus 3x plus 1 plus 3x plus 1 is divided by x plus 1. Okay, is divided by x plus 1. So here what is given? Find the remainder when x cube plus 3x square plus 3x plus 1 is being divided by x plus 1. So how do we solve it now? Solution. Let px, so we are taking this polynomial, px is equal to x cube plus 3x square plus 3x plus 1 plus 1. Then this polynomial will be divided by x plus 1. So x plus 1 is equal to 0. Okay. Therefore, x is equal to minus 1. We are shifting plus 1 to the other side. So what we get is, we have to find the value of x. So here x is equal to minus 1. That is the value we have. Now we will be substituting this minus 1 in this polynomial. So again, x cube plus 3x square plus 3x plus 1. Okay. So that is equal to x cube minus 1 bracket cube plus 3 into again x square. So minus 1 bracket square plus 3x, 3 into minus 1, and this is plus 1. Okay. So minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. Now minus 1 cube. So minus 1 into minus 1 will be plus 1. Then again plus 1 with another minus 1 will again give us minus 1. So minus 1 cube will give us minus 1 plus this is minus 1 square. So minus into minus plus. So this becomes plus 1. 3 into 1 we are getting plus 3. Then this is plus 3 into minus 1. That will give us minus 3. Plus into minus. And the fourth is plus 1. Okay. So what we are getting is minus 1 plus 3 minus 3 again plus 1. Okay. So minus 1 plus 1 will get cancelled out. Plus 3 minus 3 also will get cancelled. So what we get is 0. So the remainder, if this polynomial x cube plus 3x square plus 3x plus 1 is divided by x plus 1, what will be the remainder is 0. Understood? So find the remainder. Well, this is being divided by x plus 1. So this is how we have solved it. Let px is equal to x cube plus 3x square plus 3x plus 1. X plus 1 is equal to 0. Therefore, x is equal to minus 1. Again, x cube plus 3x square plus 3x plus 1. We are substituting the value of x here. Minus 1 bracket cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. So what we get is 0. Okay. Now the same, I'll rub this out, and the same polynomial will be dividing with some other number or with some other expression. Here it is x plus 1. So next we'll solve it with some other number. So now here we are dividing this polynomial by x minus 1 by 2. Okay, x minus 1 by 2. Okay, so same thing here we are taking this now. X minus 1 by 2 is equal to 0. Therefore, x is equal to 1 by 2. It becomes plus 1 by 2. We are shifting minus 1 by 2 to the other side. Now we have to substitute this value of x again in the same polynomial. X cube plus 3x square plus 3x plus 1. So again 1 by 2 cube bracket cube plus 3 into 1 by 2 square plus 3 into 1 by 2 plus 1. Okay. Now 1 by 2 bracket cube will give us 1 upon 2 into 2 into 2. So 2 into 2, 4, 4 into 2, 8. So we will get 1 upon 8 plus 3, 1 by 2 square, bracket square. So that will again give us 1 by 4. 2 into 2 will be 4. 1 into 1 is 1. Plus again 3, this is 1 by 2 plus 1. Okay. So what we get is 1 upon 8 plus 3 into 1, 3 upon 4 plus 3 into 1 again 3 upon 2 plus 1. So that 1 will become 1 upon 1 because we have to add all of these. These are fractions and here it is a whole number 1, so that will become 1 upon 1. So here we have to find the LCM of 8, 4 and 2. 8, 4, 2. So divisible by 2, all three are divisible by 2. So 2 4s are 8, 2 2s are 2, 2 1s are. Again 2, 2 2s are 4, 2 1s are, 2 1s are. Again 2, 1s are, 1s are, 1s are. So 2 into 2, 4, 4 into 2, 8. So here the LCM is 8. Okay. 8 divided by 8 will be 1. 1 into 1, 1. Then plus 8 divided by 4 will be 2. 2 multiplied by 3, 6. Again plus 8 divided by 2 will be 4. 4 multiplied by 3, 12. Plus 8 divided by 1, 8. 8 into 1, 8. So what we get is 1 plus 6, 7 plus 12, 19. 19 plus 8, 27. So what we get remainder is 27 upon 8. This is the answer, the remainder. So find the remainder when x cube plus 3x square plus 3x plus 1 is being divided by x minus 1 by 2. What we get is the answer is 27 by 8. You got it? The same method. So this is how we are solving the sums under remainder theorem. Okay. So that's all for today, and kindly subscribe to my channel and my video also, and press on the bell icon. Okay, thank you.